So folks, in the second video, we're going to review a couple of other problems that we've already seen, and hopefully this will help clarify some of them. But the first thing is that on the previous page, I asked you to work a particular question, and here is the assignment. Here are the answers to that, so you can access them. All right, so we saw this problem, or a problem very similar to this, in our pre-work for section 2.2, and in that I kind of said, well, I said, here's a technique we'll learn. And we haven't fully developed the skills that we want. But when I asked students to try to mimic this in class, I noticed there were some errors. So the first thing I want to do is I want to go ahead and rewrite the original expression, but I'm going to do it so in factored form. So this factors this way. Now, when I say that I had some students make some errors with this problem, we have not finished completing taking the limit. So the question is a limit question, and we continue writing the limit until we're done, until we've actually evaluated the limit through some sort of operation. So notice that step there. If you do not have this limit, I can't give you full credit for doing this problem correctly. It may seem like I'm splitting hairs right now, but you will find that this is actually a critical feature for doing these problems, and so it's essential to me that you keep writing this limit expression until you're done, until you've actually evaluated the limit. So what we said in the in-class work was we could then write this as the limit as x is approaching 4 of 1 over x plus 4. Now you should be a little bit perplexed why, not why these cancel, you can see that those two expressions cancel, but why this answer should be the same as this answer, and that's something we will address in the middle of next week. But at this point, what I have is a limit, and in this case, this expression is defined at x equals 4, and so what I can do is something called the direct substitution property, which again, we will be discussing next week. So at this step, I'm going to apply the direct substitution property, and this gives me 1 over 4 plus 4, or 1/8, which is the value of this limit. And the key thing that I want to point out to you, the reason why we're doing this in a review video, is that I kept writing that limit expression until I applied the direct substitution property, and now I have no limit in this part. So once I said, okay, now I'm going to actually plug in the value 4 into this expression, you should be confused by this. You should say, I don't exactly know what you mean by the direct substitution property, and that's okay. We're going to talk about that next week. But anyway, this is the step where we apply the direct substitution property and we stop writing the limit. Okay. We saw this in our section 2.1 pre-work, and so I want to go through this now. A fundamental question, and one central to calculus, is how do we calculate the slope and the equation of the tangent line? The tangent line is the thing that we're interested in finding an equation to that line, or at least just finding the slope of the tangent line at a given point. We're going to learn a whole bunch of techniques for doing so, but first we have to have a general understanding of these working components. So I asked you to do this in one of your in-class works, and I want you to go through it now. So pause the video, take a few minutes to work through this. Please, folks, if you just continue the video, you're not going to encounter the level of struggle that you need to in order to really know what's going on with this video. So pause the video, work through as much of this as you can. It may take you 10, it may take you 15 minutes, and then resume the video when you feel ready. So folks, I really hope you did take the time to try this problem out on your own. Otherwise, what I'm about to say will not be nearly as meaningful. So in following the directions here of what we were given, I went ahead and labeled the point P this way. There it is. We're used to maybe labeling this as x1, y1 in earlier math classes, but we need to learn this advanced function notation, and so I'm labeling the point a little bit differently, saying this is an x coordinate, and if I know a function, that's how I'd find the corresponding y coordinate. Similarly, we labeled the point Q as a plus h, f of a plus h. And so in this case, you should be wondering, what does h represent in this problem? And here I want to show you this. So if this is a, that's the x-coordinate a, right there, then this point right here, we're calling it the coordinate a plus h. So what does h represent in this problem? This is the $100 million question. If you can understand this, then you will understand this notation. So take some time. Please, folks, don't feel bad if it's not making sense right now. You just want to spend some time struggling with this. And hopefully by the end of this chapter, you'll understand what we mean by a plus h. So keep struggling with it, but I want you to think about if this is a and this is a plus h, what does h represent? What does it stand for? The next thing is of course, this is our strategy. So our goal here, as I've labeled here, our goal here is that we want to find the slope of this tangent line. Our goal is to find the slope of this green line right here. And our strategy is, rather than answering the question that we were asked, finding the slope of the tangent line, we instead want to find the slope of the secant line, because we know how to do that. If we crunch these numbers right here, we'll have the slope of the secant line. Now, the slope of this secant line is not the same as the slope of the tangent line. But notice, for example, they're at least both negative, right? And even though this red line, the slope of the red line is just our guess for the slope of the green line, we can improve this. So at this point, the slope of the secant line only slightly resembles the tangent line. But we can improve on this. How? Well, instead of using this Q1, we could use this point Q2 here. And what I'll do is I'm going to let h take on a smaller number. So if h were a smaller number, then this point Q2 would have the ordered pair a plus h, comma, f of a plus h, but h now is a smaller number, meaning that this point right here, the x-coordinate has been moved closer by letting h get smaller. So if I let h get smaller, then that will bring this x-coordinate closer to this x-coordinate. And now, if I go ahead and construct the tangent line, or the secant line, connecting these 2 points, let me give it a shot here. Okay, folks, this is in OneNote, so it doesn't work the best. Oh, no, that's pretty ugly. So, folks, you'll have to bear with me. I tried to make this line right here. I can't do it very well. On OneNote, I really need a ruler to be able to do it. But it's supposed to pass through the point P right here and the point Q2 right here. And so this is the slope of the secant line of a passing through 2 points where I kept P the same, but I moved this other point closer by letting h get smaller. And notice that still the slope of this second red line still does not match the slope of the green line, but it's a better approximation. So my question for you, is this an improvement? And the answer is yes, it is. And my question for you is, how can you get a better approximation for the slope of this tangent line? What are you going to do? Okay. So what I ask you to do next is to plot an arbitrary point on F near point 2. So let's go ahead and do so. I'll put it right here, and we'll label it QN. And notice that this will be an even better approximation. At this point, this red line is really starting to resemble that green line there. So here is the whole gist of this. What we see is that if these points that I'm calling Q with a little subscript on a number on them, as those points, the Q points, approach point P, then the slope of the secant line approaches the slope of the tangent line. For this to happen, what needs to change? Well, look at how we've labeled these points Q. We've always labeled them as A plus H, and we need A plus H to get closer and closer to A. For this to happen, H must approach 0, and that's the key of it. Okay. So I'd like you to go ahead and try, this will be graded, go ahead and write 1 or 2 complete sentences explaining this bullet point. Don't stress about it, folks, but give it a good faith effort, try your best. And then watch this demonstration, which will hopefully give you a better visualization for this, and go ahead and answer this question. This concludes my pre-work videos for this, folks. I do have some problems on the next page, but what I would like you to do is try them, and then I will include a solution link on the bottom. So you try them on your own, and then you can access the solution that I'm creating for you. Thanks, folks, and let me know if you have any questions.